Oh my gosh. Everybody's doing okay? You guys, no questions? I find that interesting because I still have only one person that's turned in any homework past 3-4. So that concerns me.
Where is this homework? Sorry.
How do you mean, where's the homework? Do you mean what the assignment is, or do you mean where to turn it in?
Oh, the 135 is. Oh, never mind.
Okay. Even if, well, anyway, even if I forget to put a place to turn it in, well, you just remind me, but then you can still do it. I mean, you got all the assignments. But yeah, the places, there's two ways you can find the place to turn homework in. You either go down here and you'll see turn in chapter 3 homework. Yay. I haven't turned this one on yet because we're not in chapter 4 quite yet. But also, let me see, let me become a student. You'll see a little to-do list over here. And you'll see all the due dates with all the homework assignments. So if you click on one, it'll take you to where to turn it in. Start assignment. That's weird. What happens here? Oh, there you go. Okay. All right, let me get out of here. Leave. All right. So any questions from homework or technical questions or anything?
No.
Okay. All right. So So we're just gonna all right, let's do this. Let me show you something here. I'm going to show you one that's not controversial and then one that might be. All right. Actually, let me turn off mute my email so it's not bothering us. All right. Bum, 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 bum. Okay. Can you guys see some fuzzy graphs here? Little blue dots, little blue measles. Yeah. So what this is occurrence of skin cancer versus where the state is, right? So the higher the latitude, the more north the state is. All right, let me make sure. I really want you guys, don't get too confused about the freaky units and whatever. This is basically mortality. This is like the rate of people dying from skin cancer. And this is how north the state is. What's the general trend?
That the more south you live, the likely you're to skin cancer.
Yeah, the more likely you are to die from skin cancer. Okay.
Yeah.
Does that make sense?
Mm-hmm.
Does that make sense?
You live close. I mean, you're more likely to get skin cancer in a hot climate, right? And the more south you live, the hotter it would be.
Sunlight, exactly. So if you're more north, you have less direct sunlight. And a lot of the northern states get more cloud cover and stuff like that. So if you're more south, you get more direct sunlight. So this just kind of makes sense. And here you can see, what in the world is this red line trying to do with this data that we have? So each of these little dots represents a state.
It's a trend.
All right, it captures the trend. The really cool thing about it, all right, I really want to make sure everybody is with me. So like this state right here is very far north and it has a relatively low occurrence of skin cancer deaths. You guys with me? That state right there. This state right here is pretty far south and it's got a very high occurrence of skin cancer deaths. Okay. Maybe. So you can kind of see the trend already. Now, what this line does, this is such a cool freaking line. Okay, all right. What that line tries to do is it tries to visually average where all the points are. It is a visual average of where all the points are. So let me ask you a quick question. Listen, listen, listen. Everybody listen. Write these numbers down. If I said it had 10, 11, 12, right? Those are my numbers, right? 10, 11, 12. Why do you automatically know? Well, all right. Let me see. Let me do this. 10, 11, 17. Make 12, 17. So 10, 11, 17. Can somebody tell me why, without doing any work, why you know the average of 10, 11, and 17 cannot be 20?
Because it's not within those numbers.
Exactly.
Within 10 and 17.
I love it. So the same thing, why would 9 not be an average for 10, 11, and 17? Because it's not within. So why would 11 not be the average of 10, 11, 17? 11 is inside of there, right? So why would 11 not be the average of 10, 11, and 17?
Because it's in the lower half of 10 through 17.
Exactly. So the average should sort of be in the middle of all the data, right? So 11 is like 17 should pick the average up higher. Is everybody semi with me? We all kind of understand averages. So what, maybe? All right. So what this picture, what this line tries to do is it tries to be right in the middle of all of the dots. So any other line I drew would be further away from the points on average. That is the absolute best line to draw that minimizes the distance to all the points. Are you guys at all with me? I don't want to make this too freaky because we're not going to get too deep into this. But just the idea that that's a visual average. So then I could predict for my state how much skin cancer death I could expect, right? I mean, for some other state, I could just use this line. So if I knew I was here, I could say I would expect about this much skin cancer death right there. Right? Maybe, no, maybe. So that's why we use trend lines to try to predict things. Okay. So let me show you another one. Okay. This one's going to be, I have no idea. This one could get me in trouble. I don't know. I can't see you guys, so I don't know if anybody's wearing a red hat or not. Some of you guys understand what that means. I don't give a shit. So here's the data. Here's something that I did myself, and I made my statistics students analyze this for their final. So here's the percent of the state population holding at least a bachelor's degree, right? So the higher this goes, the more bachelor's degrees there are, versus the percent of the population that voted for Trump. So what seems to be the trend? I just lost somebody. Oh boy.
More educated people, the more educated you are, the less likely you voted for Trump.
And just to be a little careful here, this is true data. You can't escape this being true data. Listen. Don't get me wrong. I think you might have picked up through the semester that I have a bend towards the left a bit, towards reasonable. Anyway, sorry. But this doesn't say anything about individuals, right? This says something about states. So this doesn't say that only uneducated people voted for Trump. That's not what this says, because this doesn't say anything about individuals. Does everybody understand what I'm saying? So if you are a Trump supporter, I am not saying anything about you because I can't. This data is about states. But this data is still true. Okay, I like it. So what this shows is, as for a state, as more and more people in that state hold a bachelor's degree, less and less of them seem to have voted for Trump. that does not mean, now here's the big thing. Just because I see a relationship between two variables, in this case, percentage holding a bachelor's degree and percent voting for Trump, that does not mean that one causes the other. There could be something else going on. You guys with me? Is a bachelor's degree the only way to become educated in this world?
Absolutely not. Because
No.
I
Absolutely
want to
not.
point out, I know people with bachelor's degrees and they're dumb. So
Exactly.
They're not very
I
smart.
like to tell people, I know I'm a college professor, but don't let school get in the way of your education. I actually strongly believe in that. Even though I'm in the system, I still think that you can get, obviously, you can get great things from education in college. That is definitely not the only way to get educated, right? Is everybody with me? So I really want you to understand, I obviously have feelings about this, my own personal opinion. The data does not necessarily say anything, because again, this doesn't mean, anyway, all right, that's enough of that shit. So maybe I shouldn't have shown this, but I don't care. I still like this fact that it's such a strong correlation. All right, so correlation, analyzing data and trying to see, is there a trend to the data? It's kind of like a first step in some statistical analysis. Let me take that away in case that's hurting anybody's eyes. So we like to see, so let me tell you this. Okay. Let me tell you this. Let's say that I go around and I watch people playing basketball. You with me? I go around and I watch people playing basketball. And then I say to myself, the more people play basketball, the taller they seem to be. So basketball makes you tall. Interesting. I should start playing basketball so then I'll get taller. Does that sound reasonable?
No, that's an incorrect correlation,
Exactly. Well, it's a correct correlation.
but it's
It's an
backwards.
incorrect assumption about
Yeah.
what causes what. You guys all with me? Maybe? All right.
Yes.
So that's kind of a really stupid example. I think you guys would agree that whoever this researcher is kind of stupid. but there are less obvious examples where people see a connection and they say, oh, this causes this. Like, for example, we go to this is huge. All right. I don't know how old you guys are, if anybody remembers this. Mediterranean diet. Has anybody ever heard of the Mediterranean diet?
I have.
Okay.
Yes.
And I don't know if it's the same nowadays. It's probably not. They probably become a lot smarter and realized it's more raw vegetables and less processed stuff. But back when I was a little kid, everybody thought it was the olive oil. So what did people start doing? They didn't change their diet at all. They just started throwing olive oil in everything, right? Like, well, obviously, they eat a lot of olive oil and they're all in great shape. So the olive oil makes you become in great shape. So, oh my God. Or what is that? More recently, it's the apple vinegar or whatever the hell it was. There was some movement for a while that was
Yeah, apple cider vinegar.
apple cider vinegar. Yeah.
That's right.
Oh my God. You guys understand what I'm trying? Have any of you heard of this kind of thing? Not the Mediterranean diet, but you often hear people that do this seem to be this way. So that means doing this makes me this way. No, you can't say. So that's why something like this would be a first step in a statistical analysis. Are the variables related? And then the next step would be, does one variable cause the other one to change? Like if I do just drink more olive oil and change nothing else, what would happen to me? Probably not good things, right? Has everybody ever heard of the documentary Super Size Me?
Yeah, we watched it in Home Foods.
There you go. All right.
I've seen the stoner version, I think, but there's like another version of it.
There's a stoner version of a lot of different things. Yeah. So that was sort of a study, but not really. It was kind of, we already knew what was going to happen, but It was kind of horrific watching it happen. All right. So everybody's gotten ready for today, right? I told you what I wanted you to do. So let me show you where this is. Even I got mine printed out too. We're going to do some neat camera work today. So in case you didn't do this, go to Canvas. And I told you, if you don't have a printer, you can still kind of copy this down. All right, where is it? Here it is. Lines and correlation. So this sheet right here. Okay. All right. So here we go. We're going to do some neat stuff. Can everybody go get that? If you can't print it out, you can copy it down real quick. Try to get some graph paper at least. If you can't do that, it's okay. This is going to be an estimate we're doing. And this is, I should have put labels. I'll do that first thing when I put it on the camera. This is the number of hours studied versus mistakes made on a test. All right, so let me stop sharing it this way. Oh, let me get ready here. All right, let me share it this way. Okay, this is gonna get neat. Everybody get ready. Oh, let me do this.
I'm sorry. Where is it at? It's not under grades. It's under where?
So, all right, let me show you. Hold on. Let me come back. All right. All right. If you go to Unit 3, because we're in Chapter 3, you see all these, there's problems. Yeah, lines and correlation. Yeah.
Thank you.
All right, now give me a minute. Let me orient my camera. Oh, I got to turn off my background. Give me a minute. You guys can get ready. Print it out if you haven't printed it out yet.
Does anybody else not see it under Unit 3, lines and correlation? I might be the only one. But
I see it.
You see it? Okay. I always show my iPad thinking you can see it, but
Do you see word problems?
yes.
Do you see graph basics practice?
Yes. And then nothing. And then it just ends.
All right, have you been logged into Canvas for a while?
Yeah.
Oh, then log out, log back in. You might need to
Okay.
refresh.
Yeah, maybe.
All right. Because I think I made that active. Well, I made it active yesterday. But who knows?
Yeah, we'll check.
All right. Hold on. Now I got to remember what I was doing. Oh yeah, let me turn my camera off so you guys don't get motion sickness. All right. This is gonna be neat. All right, hold on. I should have practiced this earlier, but too bad I did not. All right, this is gonna work. All right, let's see what that looks like. I'm gonna have to adjust this a little bit. Hey, look at that. All right, let me move this out the way. Doobie doobie doobie. All right, how's that look? Well, that looks very out of focus. Hold on. There we go. Oh, that's gonna freak me out. Everything's backwards. Okay, I can't look at the camera. All right, everybody can see that?
Yes.
Yes.
Okay. And I love it when people ask, to be honest, I just did what I hate. I hate it when people are like, can you see that? I'm like, I can see something. So, I always hate that. I'm like, what do you want me to see? So you can see my hands and stuff. Okay. If you don't have a ruler, I happen to have sitting next to me a Band-Aid box. So what I'm going to try to do, and this almost will definitely take 2 attempts. I'm going to try to draw a line that kind of goes right down the middle. So you can kind of see the trend, right? It goes down, obviously, right? So I'm going to try to draw a line that goes right down the middle of the data. So let me just sort of do a shitty job almost on purpose here. All right. So what's wrong with that line? Why is that not a good averaging? Is it too high, too low, too left, too right, too?
I think too high.
That's too high.
Too high. I like it. So let me erase this. Horrible, Jeff. What the hell, man? You did it on purpose. Oh, yeah. All right. Now, I'm probably going to have to do it 2 more times because when you really try, it still could get really wrong. So let me try again. Let's see. You really, really try this time. Let's see what happens. All right. That really sucks. I have to do that. Oh well, my poor little Band-Aid box is not. What do you guys think?
That's pretty good.
It's not bad. There's one little thing wrong with it, sort of. There's like these guys are a little too far away, but let's not get too picky. So I'm going to stop right there. All right, now can everybody do that yourself? And again, you might have to do it more than once. That's why I'm using a pencil. But I can't use a pencil. Hey, you can, because you're not going to turn this shit into me. So you can use a pencil on this. That's fine. No, what am I talking about? I always want you to use a pencil. I'm being dumb. Oh well, it's too early in the morning. Using a pencil is perfect. Don't use a pen. Now, I got lucky. I didn't try to do this on purpose, but did my line go through a data point?
Yes.
Yes. Does your line have to go through a data point? No. So if you draw a line and you think it's good and it doesn't go through a data point, you're fine. All right. Is everybody doing okay out there? You guys ready for the next step? And again, it's perfectly fine to erase it if you're like, nah, that's too low, that's too high, the points are too far away on this side. That's fine. But let's not be too perfectionist about this. All right, now, let me see if I have any good options here. All right, what you want to try to do is you want to find 2 points that your line goes through for sure. Now, what sucks about mine, this is kind of nice. I have a point right there. And again, if you don't have one, it doesn't matter. It would be great if my line went through like a point like this, if it went through a corner. Do you guys understand? Because then I could see it would be like 12, 13. That would have been great to go through that, right? But I really want you guys with me. I want to be able to identify another point that the line I drew goes through. So look right here. Is that, can somebody identify that point easily? What's that point right there for me?
10, 12.
10, 12. I like it. And of course, this point, what's this point? This is going to be
8:15.
oh,
Oh, 7:15.
7:15. I like it. Now, again, please, I really would love it if nobody else had those points. I want everybody to have your own points. We all draw our own line. If you do happen to have one of these points, that's fine. But I really want, is anybody confused about what's happening? So find 2 points that the line you drew goes through. Okay. Now, I'm going to do this work with my points, obviously. We can find the equation of the line, can't we? I can find the equation of this line because I have 2 points that it goes through. Remember this little equation we created last time? Maybe? No?
Yeah, I know that equation, but
We talked about it yesterday, I'm pretty sure it was yesterday. So we have this one, and then we just created this one, where this is any point and this is the slope. So let's all find our own slopes. Here we go. How do I find the slope between 2 points? Ooh,
y2 minus y1 over
Yes.
x2 minus x1.
So I feel really bad for you guys if you didn't get as lucky as I did. But my slope is going to come out really nice. Your slopes might not come out nice, and oh well. So I would do like 12 minus 15 divided by 10 minus 7. So I happen to get a beautiful slope of -1. Now I'm almost betting on some of you guys are going to get like a slope of -0.9 or -1.2 or something. So I will allow you to round it to 1 decimal place. Are you guys doing okay out there? Are you guys like, what is this stupid shit we're doing? I never know. All right.
I have same as you, but I have a different line and different points.
Oh yeah, it's possible. All you have to do is like, if I move this line up or down, it would be the same slope. Yeah.
Yeah.
All right. So you got lucky too. All right. So now, so here, let me pretend. All right. Maybe, do I want to pretend? No, screw it. It's too bad. All right. So now what I'm going to do is I'm going to pick one of my points, and I'm going to go ahead and pick this one just because that's the first thing I thought of. So I'm going to pick a point. And now I can throw everything I know, and you can do the same exact thing I'm doing. I can throw into this equation everything I know. Y minus the Y piece, right? The Y piece. Jeff, don't look at the camera because you're going to get, oh, okay. Equals M times X minus the X piece. Now, again, if you have like a decimal here, all right, you got your calculator. Don't freak out. All right. So now if I do my stuff, I'm going to multiply this through. And again, if you have a decimal, you just throw in the calculator. No big deal. I'm lucky here. So then I get Y equals -X plus 22. That's what I get. So just to show you, let's pretend like I got -0.9 instead, right? Let's just pretend that. Let me show you how it's not that horrible. So it would be -0.9 times X minus 7. -0.9X plus 6.3, right? Just throw that in the old calculator. And then add 15. Throw that in the old calculator if you have to. -0.9X plus 21.3. It's not that bad, right? It's really, even if you get a decimal, who cares? Okay. Man, this is one I definitely, it's a lot easier for me if I'm in the classroom and I can kind of walk around and see what the shit people are doing. Okay, I'll see you. Can you guys, I'll start it off. Can you guys put in the chat the equation you got? I need my keyboard now. Come here. There. I'll even put the other one I got. There. Can anybody else please, or if you can't put it in the chat, then ask me for some help. There's one. If I don't see your answer in chat, you better be asking me for help. Okay.
I'm not gonna lie, I kind of used the points that you had. It was an accident, it happened, but
It was an accident? Or did you draw a line that just happened to have the same points?
yes, I drew a line and then I found the nicest point and I chose that and it turned out to be 715 and then
Okay, that could happen. And Caitlin, I think you mean a negative slope, right? It's got to be negative because it's going down.
Yeah. Those damn net.
You're fine. Oh man, I want to be able to tell you guys the actual answer. Hold on. Keep going. I don't see everybody's answer in chat yet, and nobody's asking me for help. So that means you all got it. So put it in chat, please. Or it could be like, ooh, this means this person's not here. Okay, are these the only people that are actually here? What's going on?
Mine's not in chat, but I'm slow in writing the doc.
Okay, thank you. See how easy that was? Just tell me what's going on. Hey, look at that. That's a nice one, Ethan. I like it. I think you're actually close to the real answer, to be honest. Let me see. I'm trying to get these points in so I can tell you what the actual answer is. All right, Jeff, you can do it, buddy. Can you do it? I don't know anymore. All right, let's see. There we go. Has anybody else told me? Oh, there's Sabrina, I think. And again, Sabrina, I think you mean negative x, right? No? Do you mean positive x?
And Professor, how does it work like that? X plus the total, if I add X and Y, the point together, give,
Where'd you go? What?
sorry. I wanna just see the Y equal X and plus the number, the total between X and Y.
No,
That's
it
is work.
listen.
Yes,
Because my slope was -1,
yes,
this works. Because look, if I add x to both sides, what do I get for my equation? X plus y equals 22. That's what you're saying right now, right?
yeah.
Because my slope was exactly -1,
Oh, okay.
that is a coincidence. That is yeah, so be careful. You can't always just add these together and it tells you something.
Yeah, but just me and you, because we have only -1, maybe because that.
Yeah, and some other
Yeah.
people were lucky too.
Okay.
All right, everybody's getting the same answer, which is statistically impossible, but that's all right. There we go. So let me show you what the actual answer is. Let's see. In fact, let me even go further. Hold on, let me show you some cool shit here. All right, oops, I forgot to do this. Oh wait. Hold on, everybody. Old man trying to do shit. Hold on. Damn it. You crazy freaking. There we go.
Could you please explain where you're plugging these numbers in? Because I don't get it.
What? I'm sorry?
For your problem, the y minus y equals m, the equation, where are you? I'm
Where?
confused.
What 2 points did you get?
I got 3, 17, and 17, 8.
All right. So now you have to find your slope. Did you do that?
I was looking at the other equation. X.
Yeah, because this is the equation we want to eventually use. But
Yeah,
to
that's what I was looking at.
I need to know what m is first.
Okay.
Figure out what m is. So like if you call this one x1, y1, and more of an x. And this will be x2, y2. Now you just throw numbers in, right?
Okay, thank you.
Sure. All right, let me see what I got here. All right. All right. Look at that. Don't you wish you knew how to do that? Or no, you're like, I don't care, Jeff. I understand. And here's the right equation of the line. Oh man, this is going to be too much. Look at that. All right, hold on. Let me make this better. There's the correct equation. The slope should be, now see how they use an A instead of an M? Because stats people are like, we're not math people. The slope should be negative 0.88, basically. So I think Ethan got the closest to it. And the y-intercept should be 20.5, basically. So the correct answer should be y equals negative 0.88x plus 20.5. That should be the right answer. But why is it okay that nobody got that? Because we're all doing this by frickin' hand. Right? Of course the calculator can do it because that's what it's built for. Can a calculator play a violin? No, calculator, get out. So of course it can crunch numbers great. That's who gives a shit. Right? All of us got pretty close. Negative x plus 22, that's not horrible. Negative x plus 22, I got kind of close. Everybody got kind of close. Are you guys understanding what's happening out there? So let me ask you this. Let me take the right answer. Let me make it even better. Y equals negative 0.9x plus 20.5. All right, now somebody help me out. Can somebody remind me, what does the x variable mean? What's the x variable stand for in this problem?
Hours studied versus.
Hours studied. I like it. And then y, of course, is mistakes made. So let's say that you study for 15 hours. Can you predict how many mistakes you're going to make based on this analysis we did? How would you predict? What would you do?
The
Yeah,
you
just,
multiply it by the hours studied.
yeah, just throw 15 in. So if you do that in the calculator, let's see what you guys get if you do that in the calculator. You can do it, Jeff, 13.5. I think it's 30. No, that can't be right, Jeff. Are you doing that in your head right? No, you're not doing that in your head right. Oh, I see. Negative, Jeff. 13.5. I think it's negative. I think it's 7. Nobody can help me out? Is anybody doing this for me in the calculator? Holy shit, what did I do? Oh, I put 7 in there, Jeff. Good job. Holy crap, an F. All right, let's try this again, Jeff. You can do it, buddy. There we go. There it is. Okay, 7. So if I study for 15 hours, I can kind of predict I would make about 7 mistakes. If this data is, accurate, right? So anybody, you guys hate this? You guys hate this a lot? You guys want me to stop talking about it?
I'm confused again.
Why?
The 9 is the previous answer you got, correct?
So what I did was this is the correct answer, right?
Mm-hmm.
Just to make it easier to look at, I rounded that to negative 0.9.
Okay, thank you.
That's all I did. Yeah, I'm sorry. And then, so to estimate how many mistakes I would make if I study for 15 hours, I just got to throw 15 into the equation. So if you're like, what if I study for 3 hours? How many? And then you can plug a 3 in here.
Okay, I get it. Thank you.
Yeah. So this correlation is good for planning. It's good for estimating, what to expect. It doesn't mean it's definitely going to be that many. It just means you should expect around that. Okay, maybe. All right. That's enough of that because you actually don't have any assignment from that section, so I'm not going to spend a ton of time on that. Okay, hopefully that wasn't so horrible. All right, let me reorient this. Oops, let me not do that. There we go. All right, everything's all freaky. All right, do I still exist? Yes, okay. Oh, I'm all fuzzy. I'm all fuzzy. Bam, and my hair is like straight up. What the hell? All right. So one more thing we're going to do today. Come here, keyboard. Go away, Band-Aids. Thank you for your service. All right. We're going to look a little bit into chapter 4. Just a tiny little bit. And then we're going to head out. Let's see. Oh, well, yeah, that's all right. So in chapter 4, it kind of gives away what we're going to get into. So we've been living in a very linear fashion for a while. So now we're going to start getting into curvy equations, right? So some parabolas, some who knows what. So basically, mostly parabolas. Has anybody ever heard of a parabola? What's a parabola? Anybody? Parabola. More than one bola. Parabola. Anybody? You guys out there? Am I alone?
No idea.
No idea.
Sorry, my mic was muted. It was it's the big curve, like the big canyon, right?
Yeah, okay. If I ask you, can you right now on a piece of paper do this for me? Let's say there's a little person. Look how horrible I draw, so don't freak out. Can you draw, and here's another little person. All right, so this little person's got a baseball. Can you draw what it would look like if the one person with the baseball threw it to the other person? I really, really hope nobody does this. That would be scary for me, because that's not what happens in real life. What happens in real life? I mean, can somebody tell me what does that look like? The motion the ball would go through if this guy threw it to this guy.
It's like a little curve.
Yeah.
Upper arc, yeah.
Yeah, like that.
Right? All right, so some of you guys might have thrown it higher or whatever, but it definitely wouldn't go straight. If you threw it straight, it would go like this. And, you know, that would be like some of those ceremonial first pitches, if you ever watch those games. Anyway, so that's a parabola. So a parabola, this is a down parabola. So parabola in general, the basic parabola looks like this. Right, so just a big U, just a big U. All right, so we're going to talk about, in chapter 4, we're going to talk about the equations that lead to that kind of a shape. We're going to work with them. Let's see what we get into in section 4.1. Get out of there. All right, here we go. Blah, 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 blah. Here we go. Oh, so the very first thing we do, okay, so we're really going to sneak up on this idea like this book likes to do. We're going to talk about inductive reasoning, deductive reasoning. All right, so I love this. Okay, so let's do one thing together, and then we'll call it a day. All right, I'll let you get out of here early because I tortured you with my weird-ass correlation business. Hey, calm down over here. All right, now listen, guys. Have you ever heard of a kind of problem, a math problem, where they say pick a number, now double it, now do this, now do that? Has anybody ever heard of that kind of thing?
Yeah.
Yeah.
All right, let me make one real quick that'll do something I wanted to do. Yeah, okay, let's do this. All right, here's a nice quick one. All right, so I'm gonna. Nobody pick my number. All right, everybody needs to pick their own number. Let me get to the back here to the white space. All right, everybody pick a number. So I pick 5. So everybody pick their own number. All right, everybody got a number? Okay. Now add 2 to your number. All right. Now multiply your number, multiply whatever you have now by 3. Whoa, I got some weird. All right. Now, last step. I want you to take what you got now and subtract 3 times your original number. You with me?
Pretty crazy.
What'd you guys end up with?
6.
Yeah,
I got
6.
6.
But what number did you start with?
4.
I started
10.
with 23.
4, 10, 23, but everybody ended up with 6, correct?
Yes.
Because I'm magic.
Creepy.
Now, all right. So what I'm going to do is I'm going to show you the behind the scenes of this magic trick, right? It's kind of crazy. You ready? So what we now listen. This is cool. All right, teachable moment. We just did several examples, right? Everybody did a specific example. They had their own number they started with. 4, 10, 23, whatever else you started with. Everybody with me? Did anybody start with 6?
No, I did not.
No.
No, okay. I was just curious. It doesn't matter. Who cares? But it is so. Can you make a hypothesis? Can you make a conjecture? What would our conjecture be based on everybody's experience right now? If I do this, no matter what number I start with, so what's our conjecture?
That will get 6.
We'll
every
get 6
time.
at the end, no matter what number you start with, right? That's a great conjecture to make. Did we prove that? Have we proven
No.
it? No. Did anyone pick a negative number?
No.
Oh, maybe negative numbers don't end at 6. You with me? Did anyone pick a number bigger than 3,479,000?
No.
No. So maybe a number bigger than 3,479,000 doesn't end in 6. Are you guys with me? This is a fallacy so many people make nowadays. Well, when I did this, and when she did this, and when he did this. So whenever anybody does this, then this. No, that's a fallacy. I'm sorry. That doesn't prove shit. It's evidence, but it doesn't prove anything. So how do you prove this, Jeff? So what we just did is called deductive reasoning. Jeff, you dumbass. Let me start over. This is inductive reasoning. All right, you really? This is the big moment, and you mess that up. That's hilarious. So I remember inductive because I inflate. So from specific examples, I make a general conjecture. So I kind of inflate from a specific example. I say something about everything. Right? You guys with me? So just to kind of show you, if I would have started with 51, 51 plus 2 is 53. Multiply that by 3 and I get 159. If I subtract 3 times the original, that's 159 minus 153, which is 6. So, I mean, that's even more evidence, but I still haven't proven shit. Okay, you guys are with me? Is this a little better than the correlation thing? All right, how do I prove this then? I want to prove it. So to prove it, we got to do this thing, which Jeff screwed up just a second ago. We got to do deductive reasoning. Has anybody ever heard of deductive reasoning or inductive reasoning? Has anybody ever heard that before? No?
A long time ago.
Long time ago. Okay, so here we go. To prove this, I'd have to use every number. Do you understand what I'm saying? To prove this, I would have to use every number. We can actually do that. Do we have anything that represents any number? Yes, we do. Come on. What do we do when I want to represent any number?
What X?
X. So for deductive reasoning, we start general. We don't start specific. We start general, and then we end with specific. Now I'm going to do everything to this that I did to 5 and that I did to 51. So what's the first thing that I had to do? I had to add 2 to my number, correct?
Yes.
The next thing I had to do is I had to multiply it by 3. And if I do that, I'll get 3x plus 6. Yes?
Yes.
And the next thing I had to do was take what I've got and subtract 3 times the original.
X.
What do I get then?
6.
but it gets 6 and doesn't matter. So now I've proven it. Now we have proven it. No matter what number you start with. What if I start with the square root of 7? All right, you'll end up with 6 because x represents every number. So we just proved that for any number, you will end up with 6 when you do this. These are the steps I took to create this process. I added 2 to x, I tripled it, and then I said, oh, if I subtract 3 times, I'll get 6, and that'll freak them all out. Are you with me?
But X cover the negative numbers or not?
Of course it does.
Okay.
We've solved equations where the answer came out negative, haven't we? Right? So
Yes.
what could x represent? X can represent any real number.
Okay.
I like it. Hopefully that was semi-decent. Has anybody ever heard the one where it's like add the number of TVs in your house and subtract how old your cat is and blah, blah, blah. And anybody ever heard a variation on it like that? You can still do it algebraically. Okay. All right, guys. That's enough. So we'll get more into chapter 4 next time. I'll be nice on you today since I tortured you earlier. So let me know if you need to hang out. Otherwise, you are free to go nice and early.
Thank you. Have a nice weekend.
I want to hang out. I have questions.
Sure.
Can I ask now?
Sure.
Since I've missed classes and I'm behind on the homework, so I want to know, because you said to ask you about like the passing grade, and I do see that I can redo my wrong answers on the quizzes.
Of course.
Would I still be able to, do you think I could get above a passing or get a passing grade if I complete that?